Everyone, welcome to the signal system class. In today's lecture, we will discuss the various techniques to solve a given block diagram. We have already discussed the various techniques in the previous class. Today we will discuss an example. The block diagram of a system is shown in the figure 1, in which the system has been represented by a number of blocks, summing points, takeoff points, and the arrow-headed line segments. You can see in this diagram that this is the summing point, this is the summing point, this is also summing point, and this is also the summing point, which is also called junction points. This is the takeoff point, this is the takeoff point, and this is also the takeoff point. We have the various blocks G1, G2, G3 and G4, which is also called the forward path transfer function. H1 and H2 are the feedback path transfer functions. C is the output of the system, R is the input of the system. In this problem, we have to find out the closed loop transfer function C by R of the system with the help of block diagram reduction techniques. So we will solve this problem step by step. First, we find that this is the takeoff point. If we move this takeoff point before the block G2, we know that whenever we move a takeoff point before the block, that line line gets multiplied by this block. So we will get the figure as shown in the figure 2. You are seeing here? You can see we will get this figure. We moved the takeoff point from this point to this point. So G2 will be multiplied with H1. Now we find here that the blocks G2 and G3 are connected in cascade. So these two will get multiplied. So we will get a single block here, G2 and into G3. Again we find that G2, G3 is in parallel with G4. So instead of these three blocks, we will get a single block whose value will be G2, G3 plus G4 as shown in the figure 3. Now we find that if we move this takeoff point from here after this block, it will come here. Then what we will have to do? We will have to multiply one block here whose value will be 1 divided by G4 plus G2 into G3. As you can see here, 4. Am I clear? Now you find in this figure 4 that this is a loop. This is a loop. And we know that whenever we have to reduce a loop, we get the formula G divided by 1 plus G into H. We will do the same thing and we will get a single block here as shown in the figure 5. I hope this is clear. Now we find that G1 and G2 are this block G1 and this block are connected in cascade. So these two will be multiplied together. And again we have a loop. So we will solve this loop. Then this will be G1 multiplied by this block divided by 1 plus this G into H. What we have done in this formula. After solving this formula, we get this block. We will put it here. Now we have a single unity feedback system. As shown in the figure 6, we find that this is a unity feedback system. And we know that whenever there is a unity feedback system, this loop will be replaced by single block whose value will be G divided by 1 plus G. And we have done the same thing. This loop has been replaced by a single block T, and the value of this T will be G divided by 1 plus same thing G. And if we solve this, then we will get the final expression for C by R. That is C by R will be equal to G1 multiplied by G4 plus G2 into G3 divided by 1 plus H2 into G1 multiplied by G4 plus G2 G3 plus H1 G1 G2. I hope this is clear. Please go through this video again. If you have any problem, do contact me.